Hello dear students, all of you welcome to Vidyan classes. Today we will start the inverse trigonometric function or arc trigonometric function. Inverse trigonometric function. What is the inverse function? Inverse function or invertible function. In function chapter, we have discussed the definition of a inverse function. A function f so that a to b is bijective. Bijective means 1 1 and on 2. A function f so that a to b is bijective implies by f inverse is exist. If f is bijective, its inverse is exist and the function f to the power minus 1 so that b to a f inverse is exist and the function f to the power minus 1 so that b to a is called inverse of f. If f is a function, if a function f so that a to b is bijective, that means 1 1 and on 2 implies by f inverse is exist and the function f to the minus 1 from b to a is called inverse of f. From this definition, it is clear that every bijective function has the inverse. If f is bijective, then its inverse is exist. If f is the function from a to b, its inverse is the function from b to a. F inverse is the set of yx order pair so that xy order pair belongs to f. Since f is the function from a to b, f inverse is the function from b to a when f is bijective. Yx order pair belongs to f inverse, xy order pair belongs to f. We have discussed in function chapter. From this definition, it is clear that every bijective function has the inverse. If the function is bijective, then its inverse is exist. Otherwise, the inverse does not exist. For example, y is equal to fx is equal to sin x. F so that set of real numbers to close bracket minus 1 1, that is fx equal to sin x. F means sine so that set of real numbers to close bracket minus 1 1. F so that real set to close bracket minus 1 1, that is sine so that real set to close bracket minus 1 1 is not bijective as it is many one on two function. Sin pi by 2 is equal to 1, which is equal to sin pi by 2. Sin pi by 2 is equal to 1. Sin pi by 2 is also 1. Fx is equal to sin x. It is a set of real numbers. It is the set containing the elements from minus 1 to 1. That is close bracket minus 1 and 1. Pi by 2 to I pi by 2 it is minus 1 it is plus 1. Sin pi by 2 is 1. Sin pi by 2 is also 1. Sin pi it is 1. F is many one on two function. Many elements of this set correspond to one element in this set. So it is many one. Since the range of f is equal to this set, it is on 2. All are discussed in function chapter in the previous class. F is many one on 2 function. Sin pi by 2 is equal to 1. Sin pi by 2 is equal to 1. Since fx equal to sin x, f so that real set to close bracket minus 1 1 is not bijective. Is not bijective, as it is not 1 1. Since fx equal to sin x, f so that real set to this set is not bijective. That means the function defined by is not 1 1. Implies this F inverse, that is psi inverse does not exist. Fx equal to sin x, its inverse does not exist. F inverse or sin inverse does not exist. Since it is not 1 1, that means not bijective. It is on 2 but not 1 1. F inverse or sin inverse does not exist. But y is equal to fx, which is equal to sin x, and if so that close bracket minus pi by 2 plus pi by 2 to minus 1 1. But y is equal to sin x, fx is equal to sin x, from this set to this set is 1 1 and on 2. That is the function defined by is bijective. The function defined by is bijective, that is 1 1 and on 2. Implies F inverse or sin inverse is exist. F inverse or sin inverse is exist. And sin inverse such that f is the function from this set to this set. By definition, if f is the function from A to B is bijective, its inverse function is a function from B to A. That means close bracket minus 1 1 to close bracket minus pi by 2 and plus pi by 2. Graph. It is the graph of y is equal to sin x. From R2 close bracket minus 1 to 1. Sin so that R2 close bracket minus 1 1 is not bijective. But x is equal to pi by 2. X is equal to minus of pi by 2. This line is x equal to minus pi by 2. This line is x equal to pi by 2. In this interval, the function is increasing. Every increasing function is 1 1. In this interval, the function is increasing. it must be 1 1. In this interval, that means close bracket minus pi by 2 and plus pi by 2, the function is increasing, it is 1 1. Also on 2, since range of f is equal to this set. In this interval, the function is bijective. So its inverse is exist. What is the domain of this function? Domain of sin inverse is, it is the domain set, that is minus 1 1 close bracket. Range of sin inverse is close bracket minus pi by 2 plus pi by 2. What is domain? Collection of x values. And what is range? Set of all images. Sin inverse, domain of sin inverse is this set, and range of sin inverse is this set. It is the domain set, it is the range set. Set of all images is the range. In this interval, the function is 1 1 and on 2. So its inverse is exist. Clear? Clear? Okay. Note down. Second, similarly, cos so that close bracket 0 pi close bracket 2 close bracket minus 1 1 close bracket is bijective. Is the function defined by is bijective. That is 1 1 and on 2. 1 1 and on 2. The graph of the function as follows. This point is the origin. It is x is equal to pi. This line is x is equal to pi. This point is pi 0. This point is 0 1, and this point is pi minus 1. It is the graph of the cos function in the interval close bracket 0 pi close bracket. The function is decreasing in this interval. In this interval, the function is decreasing. Every decreasing function is 1 1. And the range of cos x is close bracket minus 1 1 close bracket. That means range of the function is equal to codomain set. That means the function is on 2. The function is decreasing in this interval, so it is 1 1, and range of the function is the same as codomain set. That means the function is onto. So the function defined by is 1 1 and onto. That means the function is bijective. Every bijective function has the inverse. That implies and implied by cos inverse is exist. Since the function is bijective, that means 1 1 and onto, cos inverse is exist. And if f is a function from a to b, f to the minus 1, that is called the inverse of the function from b to a. So cos inverse, so that close bracket minus 1 1 close bracket 2 close bracket 0 pi close bracket. Cos is the function from this set to this set, and cos inverse is the inverse of cos from this set to this set. Clear? Okay. Third, tan. So that open bracket minus pi by 2 open bracket to set up real numbers is a bijective function. The graph of the function as follows. This line is x is equal to pi by 2. This line is x is equal to minus pi by 2. It is minus pi by 2 0. This point is minus pi by 2 0. This point is pi by 2 0. The graph shows the function is increasing in this interval. Every increasing or decreasing function is 1 1, and the range of the function, that is tan, is equal to codomain set. That implies the function is onto. The function defined by is 1 1 and onto. That means bijective. Every bijective function is invertible. So tan inverse x implies and implied by tan inverse is exist, and tan inverse so that set of real numbers to open bracket minus pi by 2 plus pi by 2 open bracket. The tan function is bijective in this interval. Since it is an increasing function, every increasing or decreasing function is 1 1, and the range of the function is minus mean to plus infinity, that is R set. Since the range is equal to codomain set, the function is onto. As the function is 1 1 and onto, the inverse of the function is exist, and tan inverse so that real set to open bracket minus pi by 2 open bracket. Clear? Okay. 4 cot cut function so that open bracket 0 pi to set up for real numbers. That means minus infinity to plus infinity. The cotangent function is defined from this set to this set. Each bijective. That means 1, 1 and 1, 2. The graph of the function as follows. It is x is equal to pi. This point is pi by 2, 0. At x equal to 0, the cotangent is infinity. It is the graph of the function. This point is pi by 2, 0. It is the origin. X equal to this line is x equal to pi. And this point is pi 0. The cotangent function is decreasing in this interval, that means open bracket 0, pi, open bracket. Every decreasing or increasing function is 1, 1. The range of the function at x equal to 0, it goes to positive infinity. At x equal to pi, it approaches to negative infinity. Minus open bracket minus infinity to plus infinity is equal to r set. That means the range of the cotangent function is equal to codomain set. Is equal to codomain set. Since the range is equal to codomain set, the function is called onto. The function defined by is bijective, that means 1, 1 and onto. Since it is a bijective, implies and implied by cot inverse is exist. And cot inverse so that set up for real numbers to open bracket 0, pi, open bracket. The function is invertible. That means the inverse of the function in this interval is exist. Since the function is 1, 1 and onto. That means the function defined by is bijective. Cotangent function is bijective in this interval. So its inverse is exist. The tangent function is bijective in this interval. So its inverse is exist. And the cos function, that means cosine function, which denoted by cos, is bijective in this interval. Clear? Clear? Okay, note down. Fifth, sec so that close bracket 0, pi by 2, open bracket, union, open bracket pi by 2, to close bracket, pi, to minus infinity to minus 1, close bracket, union, close bracket 1, infinity, open bracket. Is a bijective function. It will be clear from the graph. What is the graph of the sec function in this interval? 0 to pi by 2, pi by 2, pi. X is equal to pi by 2. X is equal to pi. It is the x-axis, origin. It is a x dash. Y dash. This line y is equal to 1. This line is y is equal to minus 1. 0 to pi by 2. When x varies 0 to pi by 2, y varies, that means sec x varies 1 to infinity. 0 to pi by 2. X equal to 0, y is equal to 1. When x varies 0 to pi by 2, y varies 1 to infinity. It is the graph of the function. When x varies in this interval, y varies in this interval. When x varies in this interval, pi by 2 pi, this line is pi by 2. Y varies minus infinity to minus infinity to minus. When x varies in this interval, y varies in this interval. At x equal to pi, y is equal to minus 1. At x equal to pi, this line is x equal to pi. This line is x equal to pi by 2. Minus infinity to minus 1. It is the graph of this. In this interval, the function is increasing, so it is 1, 1. In this interval, the function is also increasing. Increasing function means the y increases as x increases. When x increases, y is also increases. In both cases. So the function is 1, 1. When x varies in this interval, y varies in this interval. When x varies in this interval, y varies in this interval. That means the range of the function is equal to codomain set. This. It is the domain set, it is the codomain set. The range is equal to codomain set. So the function is onto. So the function defined by is 1, 1 and onto. That means the function defined by is bijective. Since it is 1, 1 and onto. Implies and implies by, since sec is bijective, sec inverse is exist. And sec inverse, since the function is a bijective, its inverse is exist. If f is the function from a to b, f inverse is the function from b to a. So sec inverse for that. Minus infinity, minus 1, close bracket, union, close bracket, 1 to infinity, open bracket, 2, close bracket, 0, pi by 2, open bracket, union, pi by 2, pi, close bracket. Sec inverse is exist and sec function is sec inverse is defined from this set to this set. Clear? Since the function is bijective. Okay. last usage, so that close bracket minus of pi by 2 to 0 open close bracket minus pi by 2 0 open bracket union open bracket 0 pi by 2 close bracket 2 minus into minus 1 close bracket union close bracket 1 infinity open bracket is a bijective function. It will be clear from the graph. What is the graph of the cosine function? X is equal to minus pi by 2. X is equal to plus pi by 2. Minus pi by 2, 0. It is the line y is equal to 1. It is the line y is equal to minus 1. It is x-axis, origin, x dash, y dash. This line x is equal to pi by 2. When x varies 0 to pi by 2, in this interval, y varies 1 to infinity. 0 to pi by 2. When x varies 0 to pi by 2, y varies, when x varies in this interval, y varies in this interval. The minimum value is 1 and maximum value is infinity. At x equal to 0, it is infinity. So, it is the graph. When x varies from 0 to pi by 2, y varies 1 to infinity. At x equal to 0, cosec 0 is infinity. Clear? When x is equal to pi by 2, the value is 1. When x varies in this interval, y varies in this interval. At x equal to 0, cosec 0 is infinity. That means approaches to infinity. Next, when x varies in this interval, y varies in this interval. At x equal to minus pi by 2, cosec minus pi by 2 is equal to minus 1. It is a minus 1. X is equal to minus pi by 2. And minus infinity. It is the graph. Here, when x varies in this interval, the function decreases. Every decreasing function is 1, 1. When x varies in this interval, the function is also decreases. Every decreasing function or increasing function is 1, 1. Again, when x varies in this interval, y varies in this interval. When x varies in this interval, y varies in this interval. So, the range of the function is this, which is same as the codomain set. If the range is equal to codomain set, the function defined by is on 2. Since the function defined by is 1, 1 and on 2, it is bijective. So cosec x is bijective. Cosec function is bijective, implies it by. If the function is bijective, its inverse is exist. That means cosec inverse is exist. F such that A to B, if its inverse is exist, then F inverse is from this set to this set. That means and cosec inverse such that open bracket minus infinity minus 1 close bracket union close bracket 1 infinity open bracket 2 close bracket minus pi by 2 0 open bracket union open bracket 0 pi by 2 close bracket. The cosec function is defined from this set to this set. Since it is bijective in the given domain, its inverse is exist. The inverse of cosec is defined from this set to this set. Clear? Clear? This point is x equal to 0, y is equal to 1. This point is x equal to pi. It is x equal to pi, y is equal to minus 1. Similarly, here this point x is equal to minus pi by 2. Y is equal to minus 1. It is x equal to pi by 2. Y is equal to 1. From the figure, it is clear that the function defined by, that is sec and cosec, are bijective for the given domain. This function and this function are bijective in this interval when it is defined from this to this. Clear? Okay. Note down.